Thank you for coming, and I'm Yuki, and today I'll be talking about distributed block building, some designs around the distributed block building, as well as the Orderflow problems around the distributed block buildings. And I guess I hope that after this talk, you guys would have a bit more understanding around one, distributed block building, and two, some of the, I guess, big challenges that it's facing going forward. And also, just a disclaimer, like, I'm not here necessarily to specifically, show about Suave or anything, but it's certainly related. Okay, so I just want to ask, have anyone seen this graph before? Perhaps, yeah. Cool. Well, today I just wanted to modify this because I wanted to better illustrate some of the issues that I wanted to point out, which was I kind of draw it here. So essentially, the current builder landscapes, I kind of colored. Oh, is this easy to see the color? Oh shit, it's kind of hard to see. Anyway, so I colored this builder's graph with all of the stakeholders within this ecosystem in green, and then red, and then yellow. I'm not sure if you can see the red, but supposedly the builders and relays are red. And the reason why I kind of put it there is because out of all of the stakeholders that we have, relays and the builders are right now are the most centralized and also the trusted parties among the rest. And that's basically as you can see, they are a very big part of the ecosystem when you look at the sort of the points that they're interacting with. Yet we are still not really there in terms of decentralizing all those players that are playing such a key roles. And that's why also I wanted to show briefly that the stats around the block building market share. So I guess start from the builder side. I mean, if you look at this, top 4 builders, including Flashbots and maybe Beaver build guys, I'm not sure if they're here, but 4 of them would essentially already dominate around 79. So it's 80% of the market share now. What does this 80% mean? This 80% means that if you let's say send your bundles to all of those 4 builders, you have 80% chance of inclusions for the next upcoming slots. So that's probably the better way to think about this number in context. And then on the other hand, you have relays that are also fairly centralized, but also on the relay side, there's only seven big relays to ever exist. So and if in total they also control about 74% of the order flow that is going through. So this number in context basically means that 74% of the order flow that are submitted to the networks are going through these 4 relays that we see in the space. So the point that I wanted to make here is it's pretty centralized. I think and within the ethos of Ethereum, for broader decentralization and better liveness assumptions, it is crucial that we strive towards more decentralized futures, even in the stacks related to block builder especially. Relays in the future may change a bit with EPBS, but especially on the block builder side, it will persist and it will have to be better designed going forward, and which is why Suave guys are also working tirelessly on a lot of the initiatives around that. So I guess few points I wanted to make. Why even decentralized block builders? Well, first point, the lack of credible neutrality. I think, and to put it in a simple way, a reputation-based neutrality is essentially the same thing as saying "trust me, bro" neutrality, and that is basically no neutrality. I mean, you can go look at Beaver build and other even solvers or whatever that are claiming to be neutral. They always have disclaimer at the end of the doc saying, hey, I'm neutral. I'm not trying to fuck around basically. But that's basically trusting the words, and that's why I'm saying trust me, bro. Neutrality is what we have today, most of the time. And then I guess another big advantage of decentralized builders here is lower hurdle to searcher builders. So I think Dan briefly referred as well that with the distributed block builders, you can lower the hurdles for entries to searchers who can basically have more access to the slots within the block space. And then the last thing, oh, not the last thing, the second to last thing is the censorship resistant. Actually, like, I have to mention that it doesn't actually help too much with decentralization in terms of censorship resistance. And part of it is because like most of the censorship, or the biggest part of the censorship that exists on Ethereum is like economic censorship. And oftentimes economic censorship is not necessarily just the issue around like, oh, decentralizing bulk builder roles. But having said that, it is true that if you have like only 4 parties that are controlling like most of the market share, then it's a lot easier to bribe those 4 known parties over a bunch of other nodes that are running within the networks that may be not even known in the public. So it helps, but it doesn't solve completely. And then obviously the regulatory censorship issues, as mentioned, like the geographical decentralizations is another big factors associated with it. And then lastly is anti-fragility. I mean, this is like basically saying like, hey, we should have a better liveness assumptions around a lot of the block building features. Like once we lose all those big bonds, I mean, let's just say one day like I nuked like a couple big builders and boom, they're gone. Like I think we're gonna have a interesting latency on Ethereum at that point. So like that's just like a lot of the liveness assumptions and anti-fragility aspect that we should also consider for a lot of the distributed block builders. So that's why I'm interested, and a lot of people are working on these problems. So now, how can we decentralize? I think I'm gonna kind of like just briefly go through the I guess the TE model that Swav kind of alluded to, and also I wanted to today introduce a little bit more about the threshold encryption, the threshold encryption, or the MPC based approach, and then lastly we'll briefly talk about the leveraging on the Pepsi with the parallel and the sequential selection. So I guess with the TE model, I'm just gonna kind of go over how roughly it works. First of all, you will have like a network of TE nodes that are running let's say SGX chips or whatever. And then this node, because it does hold a lot of the states, I'm assuming that this TE nodes will be stateful and that they can perform OFA, different types of OFA, plus bundle merging algorithms on top of it. And then you have searcher builders that are basically submitting their bundles, their transaction, their order flow to the nodes. And so essentially, after the transaction is submitted, the bundles are merged, OFAs are performed, then the TE nodes would essentially compute all of the Merkle routes for storage and balance and transactions, and that this block header with the Merkle routes would be then submitted to the proposers, who would then say, okay, I'm going to commit to this, and then eventually the TE node would reveal everything and say, hey, this is the block body, and then now we know that okay, this is actually what's being merged and bundled in the network. Some challenges, obviously. So as mentioned, like, yes, there's a lot of problems with TE. I'm not sure if you guys are aware that even last month that there was the downfall attack that happened, well, that was discovered within the TE space that, obviously Andrew Miller is like immediately, went ahead and like patched it and was an amazing job. But again, like there's always like unknown bugs that are coming up on the TE space that is like every year getting discovered. So there's some risk associated with that. And obviously, as Matt have alluded to, ORAM helps, and other types of hardening helps, but it's not perfect. And then I guess another thing is maybe like a little bit on the latency overhead. With SGX, it's not as big of an issue comparatively, but it does add a bit of like latency, especially considering that people who are running centralized builders does have less latency overhead compared to like ones that are running SGX, for example. And the latency overhead can vary depending on how many calls you're making between the untrusted party and trusted enclaves. So if you have a lot of like a lot of calls between programs outside of the enclaves and inside of enclaves, you're going to incur a lot more overhead as well. And also the size of the program matters. So if you have if you're running a Geth or whatever, like it's a fairly sized program, then yes, there's going to be a fairly sized overhead on that in terms of latency wise. And I guess this is probably more like a narrative public perception thing, but yes, there's like a bit of like a optics where people think that the TE is not safe or whatever, even though like it's fairly well protected, but you know the optic doesn't help too much. And I think depending on the mode of operations, it can still be centralized as well. Which you know we'll see how the implementation actually works, but yeah, technically with the centralized TE, it can still do the jobs. So centralized is also a possible options. So I guess here I also wanted to discuss a little bit more about the MPC-based threshold encryption approach. So I put like optimistic here, because this model assumes that the MPC nodes do not perform validation of the states. And so I guess I'll just like go through it from the top. So essentially, you'll have searcher builders that are performing either their own OFA on their off-chain compute, or maybe on Suave or whatever, doing their own OFA stuff. And then could be going through like MEV or whatever. And then they will submit the transactions, the bundles or the order flow to the MPC network. Now the transaction will be encrypted with the encryption key, and then the MPC network would basically perform greedy knapsack auctions across all of the bundles all of the order flow that comes through. And that way, basically, they will try to like optimize the merge, the bundle merging within the MPC network. And then there's two possible routes here. Either the MPC itself have to be stateful to compute the block header for all of the Merkle trees that needs to be submitted to the proposers, or you could actually leverage something like Suave to basically perform those block header computes elsewhere. So like here, to essentially perform all of the block header, and then submit that to the proposers as a sort of like a way to get that. Now, I put the proposal here also as a conditional commitments, because if you build block in an optimistic manner, then you could also get this interesting feature with Pepsi, where you could actually say that, hey, I didn't check. It's kind of like optimistic relay. I didn't check the entire validity of the transactions, but I want to have someone else check, could be proposers or whatever, to make sure that the transactions are valid. And if not, then you can scrap away entire block. So it's kind of like the Pepsi here, a Pepsi use case here, where you enforce some sort of like conditional commitments by the proposers, such that the MPC node can itself not maintain the states, because maintaining states within MPC can be very heavy. So that's why like doing this a bit more optimistically kind of helps reduce a lot of the burdens that is associated with maintaining the states and computing the Merkle roots and whatnot. Right? It's a lot of heavy stuff. And then so that's the second one. I guess the challenge here is that, as I mentioned, like the proposal commitment needs to be conditional. And then there is going to be significant latency overhead from just the communications between the MPC nodes, and also the sharing the secrets. But however, it helps. It does achieve the reduction of the TE. So within this scheme, you do have less reliance, reliance of TE nodes, which is definitely better in terms of like more neutral as a block builder. And then this also helps, actually requires, by nature, it requires decentralizations to begin with. So MPC-based block building would be decentralized on the get-go, essentially. And then, conditional commitments. I guess one thing I would just like want to add is that in terms of like how neutral the block builders can be, it's like it's like a spectrum. And then on one hand, you have the most centralized builders that are like just trusted, and then on the other hand, you have as decentralized as possible and as trustless as possible. And I believe that MPC-based solutions by far is probably the most trustless or the trust minimized options that we have in the space, while the TE-based one is probably like sitting somewhere in the middle in the spectrum. And then the last one I wanted to kind of go over is the slot auction. And here I said like it could be sequential or it could be parallel slot auctions, and they kind of have a different implication depending on what model that you're going for. But essentially, this is also I guess should I say application of Pepsi, because you're now asking the proposer here to essentially make commitments to split the block into different slots, and then you auction it out based on whatever properties that you're looking for. And I guess one of the suggestions that I think Barnaby also made was a usage of like top and rob market, like top of block market and the rest of the block market separations. And obviously, I think there's a lot of like research that needs to go into that as well. So just to kind of like go over, so basically, proposer can partition the blocks into different portions. The searcher builder would be able to basically bid for the slot, and then each searcher builder can also enforce its own OFA, again based on like swap or whatever. And then proposer will commit to the winning bidder's block either sequentially or in parallel. And I guess one thing that I wanted to mention here is that the slot auction can be incorporated with other types of distributed builders. So I guess here I kind of wanted to introduce the idea that with distributed block builders, we may see composability within the block builder space that we may not have had much currently. And that would be possible going forward with this kind of like design in place. So like more like composable block building. But there's obviously challenges. And one of the issues around like the slots design is like, how can we even determine the slots? Like, are we just going to say that, oh, 10% of the gas from the top of the block is going to be the TOB, and then the rest of the 90% is going to be ROB? Or are we going to like have some sort of like mechanism like EIP 1559 type of things to dynamically adjust the slot width? Or what? Like this determination of the slots, in my opinion, is still like very much open-ended. So probably a lot more work and then thinking needs to go into that. And then I guess another thing is like parallel auction. So if we do perform parallel auction, what that essentially means is like a predicting block value, which in essence is a block space future, because you are trying to see ahead of the block space and say, okay, this block will probably worth this much, so I will bid this much value. And I mean, it's good and bad because there's some predictability to the cost of the block slot, but at the same time, it also adds, should I say, like inefficiency to that, because ideally the block value should be, as close to the actual MEV value as possible. So there's that, and then another thing that I guess I will just potential overhead if you're performing like sequential block auctions. So that's also why like some may argue that okay, parallel is more practical versus sequential is like you have to do it one by one and whatnot. But I think one more thing I have to add here is that parallel auctions would also get into the problem of like, okay, the proposer are making commitments to this bunch of transactions in the condition that no other transactions before this is like conflicting with it. So that's also like another constraint that is adding to the parallel auction. So both of which have some challenges, but it's also a further work of research to be done on that. So by this point, you guys might wonder, how to compete against centralized builders, right? So practically today, like centralized builders are like this, like this beefy ass, like super latency optimized, right? And then on the other hand, you have a distributed block builders, like it's so sad, like little high latency. So like, how do we even compete with that? And I think this problem, like is like even to this day is like somewhat in my opinion, is somewhat unanswered because there's a lot of assumptions that we have to make about the market structure in order for the distributed block builder to really make sense and prosper in the future. And that's not to say that distributed block builder is not necessary. I think that is absolutely necessary. But there's also aspect of like how can we align the incentive better such that distributed block builder would just like I guess prosper on its own. So I guess I just want to say, like, regarding the current block building space, if we think of all those candies, like all of the order flow that we see on the public mempool and whatnot, then this is what's happening with all of the centralized builder taking dominance on the top of block marketplace, top of block market, and then at this current scenario, I highly doubt that the distributed block builders can like sort of disrupt the market the way it wants. But here are the assumptions that I think will help distributed block builders to prosper in the future. And one of it is the value of credible neutrality. So I believe that as more builders becomes integrated, where they are doing both the searching and block building and even trading, as maybe Max have alluded to, like rsync and Beaverbuild guys are, they have some trading partnership. They're called integrated builders in the sense that they bring their own order flow. The more builders are existing like that, there's a question that pops up in the space where we ask, am I competing against the builder that I'm sending the bundles or not? And that's often a question that a lot of the trading firms, a lot of searchers ask themselves. And what do? They have to actually check out, try to send all of the bundles across all of the builders and say which builders is actually not including my transactions. Because by doing so, I can actually tell that, oh, yeah, this guy is like trying to fuck with me, so I'm not gonna send my bundles to this builders. And that's basically like the issues around credible neutralities. And the lack of it can result in the behavior like, oh, I'm just gonna try to find whoever is not competing with me, whoever is not integrated builders such that they can include my bundles. And then I guess another aspect is around the narratives and the optics. So in my opinion, I agree, like credible neutrality is a bit more like a vague terms, but being as neutrally neutral builder as possible, in my opinion, is also a big adds, considering the fact that we have had players, I mean, including Flashbots and Block Native and a few other guys, have done like OFAC censorship for understandable reasons, and that obviously harms the neutrality, but the more so it harms the fact that people just simply don't like censoring builders or like builders that are censoring. So what happens is that people just say, okay, yeah, this guy is censoring. I don't want to send my bundles to any censoring builders. I prefer to have someone that is like non-censoring to include my transactions. So what ended up happening in that case is that even though the OFAC censorship list is like maybe 10 addresses or 20 addresses, which is like tiny, but the optic of it just drives a lot of people away from sending their bundles and order flow to those builders. And that's, again, why I think that the credible neutrality aspect matters. Oh, I guess I would also add that another reason why that the OFAC censoring builders tend to have a harder battle is because some people just don't want to even like filter the bundles, because that's the added latency within this like a latency game. So they just don't bother with it. Another assumptions that I wanted to discuss here is the value of a slot over a value of a block. So as I mentioned, distributed block building at the end of the day is chopping up a massive block of transactions, now a block of a block space, into a smaller chunks that can now be controlled and determined by different actors in the space, and which I call searcher builders. And this, again, would enable more composable block building schemes like those that I kind of listed. And obviously, this is like a very like high-level abstraction of it, and a lot of details need to be more laid out. But I believe that a lot of the implementation of slot auctions with Suave and other types of like distributed block builders come into the space. More composable types of block building activities can become possible in the future. And then I guess the last point on this assumptions that I also wanted to discuss is around the distributed block builders allowing sort of like a BYOF or more encouraging more BYOF activities. So instead of like bringing your own boost, you're bringing your own order flow basically, and that's kind of like where you have, let's say, like a DApp wallets or DApp relayer or DApp specific OFA that is bringing in their own order flow directly to this distributed block builders, where they can actually have a dedicated slot of block spaces where they can do stuff. And then the third assumptions that I have here is the different latency game. So I guess one of the reasons that a lot of the latency game exists in the space is because one, every transaction is publicly available in the mempool. So basically, a lot of the transactions you see, and then the fastest you simulate the transactions and make it into bundle or make it into the block, you win. So there's a latency aspect to open informations. Two, there's a latency aspect to the transaction itself, where this transaction is trying to execute some sort of like 6-DEX arbitrage, and you have to make sure that these transactions have to be at the top of the block. Otherwise, someone else is going to capture that opportunity, and you're going to miss out on those big fat arb revenues. So I put it here that integrated builders, those who are doing tradings and searching and whatnot, will be as latency sensitive as the order flow itself. And in other words, latency matters less if the order flow doesn't have to be on the top of the block. Now, this is not to say that all of the order flow that are less latency sensitive don't have to be on TLB, but there are a subset of order flows that can, that still has a lot of MEV value, but doesn't have to necessarily be on TLB. And if you have a sort of like a proprietary access to that specific order flow and other people don't, then the latency in that case would matter a lot less, as long as the information itself is not latency sensitive. So that's why I said integrated builders will be as latency sensitive as the order flow itself. But however, I do want to mention that, but this leads to the issues around the TLB dominance of top integrated builders in the space, because right now the current block building landscape is that most of the top builders are integrated builders, and that they dominate the top of block fee market, and that if within the current block building space, if you win the top of block fee market, you basically win the rest of the block. So there is some concerns around like, okay, how can we break this dominance of TOB centralized block builders going forward? And I guess I just want to say a lot of the assumptions that I mentioned here are all like sort of like composing with each other, meaning that projects may prefer to have credibly neutral builders, hence they want to prefer to use something, like a distributed block builders, and they value the slot over the block, and they might want to also participate in OFA within a certain distributed block builders. So again, like all of this composing with each other as a more unified advantage that the distributed block builder would have over centralized block builder. So I guess in a more like a nuanced way to present it, I foresee that the future would look a bit more like, okay, you have a bunch of like a big ass, centralized block builders, but at the same time, some order flow, right? Some order flow would take some opinionated positions on how they want to even distribute their order flow to the public, and hence you see some sort of like a rock as a guardians to essentially like order to perform some sort of OFA and then put down to those little distributed block builders that are sitting around the corners. But again, I believe that the space would be quite a nuance going forward as well. Some open questions. So I think I believe that there's a lot of challenges, ahead for distributed block builders, but I think there's also a lot of like open research questions. So first of all is like, with the advent of slot auctions, would the advantage of TOB dominance diminish. So if let's say what Barnaby is trying to do with the top of block fee market and rest of the block fee market would actually become reality, then how does that impact let's say the TOB dominance that is currently presented by the centralized block builders? And then another thing is like, can credibly neutral builders provide enough advantages of order flow aggregation when competing with big non-neutral or integrated builders? I think that one is like, God knows, challenges that exist ahead in the race forward as well. I guess one more thing that I wanted to mention is that I think this is probably also like a comment to FlashBus guys. So I think a FlashBus right now, I believe, is not winning as much TOB market as well. So that to me is actually a bit of a concern because with FlashBus being able to win TOB is also a leverage moving towards the distributed block building race. So I think I do encourage FlashBus guys to be up their block building game as well. Okay, so thanks for listening, and yeah, thank you.
Any questions?
Yeah, well, when it comes to distributed builders competing with centralized builders, perhaps is there any way we can do commercialization? So it means that the public might have a chance to invest into great distributed builders, which will allow them to entitle to some future income compared to centralized builders where we can't really invest. I was wondering if we can mimic the success of distributed stakers, but obviously that's two different volumes.
Oh, as in like people would, I don't know, put stake onto like distributed block builders?
Yeah.
I mean, I feel like that's probably more on the go-to-market strategy side of things. Like it's certainly one possible way in which they can like aggregate a lot of order flows, but I don't think it's a very sustainable way either, because if the biggest order flow originators are not staking or putting their money into your protocol, then basically you get however much money that you aggregate, it doesn't correlate to the amount of order flow that you actually get for the distributed block builders. So even if like you get like, I don't know, 200 million, 300 million TVL that is staked on a distributed block builder, that doesn't necessarily mean that you are more competent against a Beaver build. So it's like very orthogonal in my opinion. Yeah.
Okay, makes sense.
Yeah, I was wondering if you could talk more about how you see like the market structure of the top of block, because I think there's some things that don't make sense to me, like, but I haven't like read any of the proposals or anything. Mm-hmm. So like the main advantage is that like right now, if you're competing in top of block and you're a block builder, you just own the whole block, even if you win the top, right? So the key part is like separating them. But if all the order flow is still going to like one builder, mm-hmm. it still effectively feels the same. And then also like, I don't know, thoughts come to mind of like, okay, so if I have a higher tip, like in this, the rest of block option than the tip in the top of block, like do I still stay lower?
Yeah.
Or like, what if I'm also like, let's say the top of block is a Dex trade and the is like an Oracle. Like if I want to do both, do I have to now compete in both?
Yeah.
Let's get like combinatorial.
Yeah. So that's again like I think that's exactly why like it's still very much open ended in terms of like how do we even go about this top of block? And I just want to add that. So besides the fact that top of block would enable, top of blocks and the rest of the block separation would enable like the diminishing of the powers in terms of the block builders, because now you're splitting these two such that one builder winning the top of block doesn't win the rest of the block, right? So that's fair. But also another advantage is that people are anticipating with this is that reduction of the fees. So you let the competition to happen more in a siloed manner such that they can like reduce the fees for the rest of the block. But that's also not very complete, because as you said, you could have an overflow where you set this to 10% or whatever, but it can always overflow across the rest of the block, which basically means that you ended up having the same gas fee curves or the bidding fee curves where people just bid like exponentially high towards the top of the block. So yeah, I think there's still very much open in research question like efficiency of the TOB and RB. But having said that, I do think that regardless of how lower the fee can go, TOB and RB can help reduce the dominance of the top of block bidders and builders in the space. Yeah, so it leaves more venue for the distributed block builders to actually prosper going forward. Yeah.
Any more questions? Then if you have more questions, come to Yuki, and we have our final guest, Sam from Skip Protocol, and we will start in 15 minutes. So feel free to discuss.